Forged, how glass is made. You interact with it dozens of times every day, and almost certainly have no idea what it is or how it got there. Your phone screen, your car windshield, your bathroom mirror, the window next to you right now, the optical fiber carrying the internet across the ocean. All glass, all starting from the same basic ingredient. This is how it works. Glass starts as silica, silicon dioxide, which is the main component of ordinary sand. Not all sand works. The silica needs to be high purity with low iron content because iron tints the glass green. The best glass sand comes from specific geological deposits in places like Belgium, the UK, the United States, and Australia. It arrives at the glass-making plant in enormous quantities and gets processed to remove impurities before anything else happens. Pure silica alone would melt at about 1720 degrees Celsius. That is achievable but expensive, so glassmakers add soda ash, sodium carbonate, which acts as a flux and drops the melting point to around 800 to 900 degrees. Then they add limestone to stabilize the glass and make it durable and water-resistant. Without the limestone, the glass would slowly dissolve in water. The three ingredients together, silica, soda ash, limestone, have been the basic formula for glass for thousands of years. The batch, the mixture of raw materials, goes into a furnace at around 1500 degrees Celsius. Inside, the ingredients react chemically and melt into a viscous liquid. The liquid glass at this stage looks like glowing orange honey. It flows slowly, it bubbles, and it contains tiny air pockets that need to be worked out. The furnace runs continuously, 24 hours a day, 365 days a year, for years at a time. Shutting down a glass furnace is a major event, because restarting requires weeks of controlled heating to avoid thermal shock to the refractory lining. To make flat glass, the kind used in windows, screens, and mirrors, the process used today is called the float process, and it was invented by Alastair Pilkington in 1952. Working at night in a Chance Brothers plant in England, he observed that a piece of glass floating on water was perfectly flat. He had the idea that if molten glass could be floated on a liquid denser than glass, it would take on a perfectly smooth surface. The liquid he chose was molten tin. Tin melts at 232 degrees and stays liquid at the temperatures where glass is viscous enough to be shaped. The float bath is a long, enclosed chamber filled with molten tin, maintained in a nitrogen-hydrogen atmosphere to prevent the tin from oxidizing. Molten glass is poured onto the tin at about 1100 degrees and floats across it, spreading out naturally under gravity and surface tension to a uniform thickness. As it moves through the bath, it cools slowly. By the time it exits onto rollers at about 600 degrees, it is a continuous ribbon of perfectly flat glass, optically smooth on both surfaces, the top polished by surface tension, the bottom by the tin. The float process is so effective that virtually all flat glass in the world is still made this way. After the float bath, the glass ribbon moves through a long cooling tunnel called an annealing layer. This is critical. Glass under thermal stress, where one part is hotter than another, will crack. The layer controls the cooling rate precisely over hundreds of meters, ensuring the glass arrives at room temperature in a stress-free state. Once cooled, the continuous ribbon is cut to size by automated scoring and braking systems. The offcuts go straight back into the furnace as cullet, recycled glass, which melts more easily than raw batch and reduces energy consumption. Different types of glass are made by changing the recipe or the process. Tempered glass, used in car side windows, shower doors, and phone screens, is made by heating the annealed glass back to around 620 degrees and then blasting it with jets of cold air. The rapid cooling creates a surface under compression and an interior under tension. This stress makes tempered glass roughly 4 times stronger than ordinary glass, and when it does break, it shatters into small blunt pieces rather than large sharp shards. That is why your car's side windows crumble instead of slice. Borosilicate glass adds boron oxide to the mix. The result, sold under brand names like Pyrex, has a much lower coefficient of thermal expansion, meaning it can go from freezer to oven without cracking. The glass in your lab beakers, your baking dish, the mirror on the Hubble Space Telescope, all borosilicate. Fiberglass draws molten glass through tiny platinum nozzles to produce fibers thinner than a human hair. Optical fiber takes that even further, drawing ultra-pure glass into strands so transparent that light can travel through 50 kilometers before losing half its strength. The glass in your phone screen is worth a separate mention. Corning Gorilla Glass is an aluminosilicate glass. It contains aluminum oxide instead of some of the soda ash, and it is processed by an ion exchange, where the glass is submerged in molten potassium salt and the smaller sodium ions in the surface layer are replaced by larger potassium ions. This creates extreme surface compression, making the glass extraordinarily scratch and impact resistant. The same basic principle as tempering, but at the atomic level. Follow Forged, how the things you love are actually made. Link in bio.